Alrighty. Hello again. So this is going to be the second tutorial of my new series, I suppose. I think with this one we're going to kind of go over a few of the techniques we learned before, and just we're going to try to build something a little more complicated, or just something that we're kind of used to. So today we're going to maybe try to get this built here, just kind of a regular bicycle sprocket, something that kind of pretty common, but has some interesting, difficult features that may be not as easy to make as it appears. So this is what we're going to try to make today, something similar anyways. I'm not going to really worry myself with dimensions, but things like these, which should encompass all the tools that we learned before. So there's kind of a drawing schematic of it there. Not really that has anything to do with anything, but all right, let's get it underway. So as before, you open FreeCAD, choose your workbench. I always like to do complete, just because I've got everything I need. I don't have to switch between workbenches all the time, which is nice. So I'm going to open up a new one, call it whatever you want. I'm going to call it tutorial2, but where am I? Way in the middle of nowhere. Here we go. Alright, so tutorial2, we're going to make a sprocket. So there's a number of ways we can go about this. Essentially everything looks like it's cut from a disk. So what we're going to do right off the bat is make a disk. So as before, you're going to open up a sketch, put it on any axes you want, doesn't really matter. So this is what this is where we'll start. So the disk was pretty thin. I'm just going to use the polyline again. I'm going to kind of make something that looks like something that we're going to you noticed at the top that it had kind of a taper edge, so we could either make that now or we could make it later. I'm going to make it right now. So there's your sketch there. Obviously now I've got to constrain it, so with everything, constraints is everything. And as you notice, remember with revolving, we're revolving about this axis, and you notice that there's nothing on the other side of the axis, so that's really important. You can go right up to the axis, but you can't build stuff past it if you're going to revolve it, because then it'll revolve through itself and it'll throw a bunch of errors and you'll be pulling your hair out a little bit. So as you can see, I've got some vertical constraints here that the computer's already kind of preconceived that I wanted. I want this one horizontal as well, so I'm going to make that. As you notice, those are not touching, and we need a closed surface. So if I were to try to extrude this, it would not like that at all. So I'm going to make these two connect by using the coincidence constraint, which is this dot one here, and it's going to bring them together. I'm going to go up here and check to make sure these ones are all okay. They all look like they're together, so that's good. So now we're going to start defining some dimensions on here. So let's make a width of this. So this is all in mils, so typical sprockets probably no more than like 2 or 3 mils wide. So well, let's make it 3 millimeters wide and see where that takes us. So as you can see, that did some pretty crazy stuff there. What I'm going to do is I'm going to throw a symmetry constraint here to make things a little bit easier. So I'm going to say I want those 2 points symmetrical about that line. Go up to here, click symmetry constraint. As you can see, it's done just that. Similarly, I'm going to want those 2 points symmetrical about that line. I'm going to do just that. I'm going to define this length here, so maybe the top edge, is maybe like 1.5 mils or something like that, something Let's make it a little bit more. Let's make it 1 millimeters. A little bit more angle there. As you can see, it's like a completely perfectly mirrored image. So there was some hole there. I'm going to make it maybe a 40 millimeter radius hole, which should give me some stuff to work with. Up here, so if you need a specific taper or something, so say you needed a specific angle or something, let's say it needs to be 30 degrees between here or something like that. So if you try to use the angle constraint, which is this one right here, you'll see that it doesn't make the angle where you want it to. So that could work. So you could do some math and kind of backtrack and figure out that that's, if we needed 30 degrees over there, then this is going to be 150. So you could do it like that. Type 150. We get something like that, which means that this one over here, since this is 180, that's going to be 30 degrees. Or what we could do is we could make another line off here. I'm going to make it a vertical constraint, and then what we're going to do is we're going to make this a construction line. So that turns it blue. So that means when this is construed, this will not exist in the construed. So I'm going to lock that end down so it kind of knows where it is. And then what you can do is you can select that and this one, and you can make an angle between those, and I'm going to make it whatever I want. So that's another way you could go about it if you wanted to, which would make things easier in the end. Maybe you need it 18 degrees or something like that, something set by the manufacturer, whatever it is, right? So you got your angle there. Let's make an overall height on this. As you can see, I'm pretty much fully constrained here, but if you look over there, it's throwing some errors. So let's just go and see which ones it doesn't like. It doesn't like constraint number 18, so you go down, I'm going to delete it. Which makes sense because kind of given some things some height. And okay, so we're all set there. I guess what I should have also done is the way I defined this line here made it kind of small, so wasn't taking into account the actual height here. So I'll make that 180 as well. There we go. Alrighty, so we kind of got the cross section of our sprocket here. So now that I'm happy and that stretch is fully constrained, I'm going to close out of the sketch, and as you can see, I'm left with this here. So now I'm going to revolve this about an axis. So I'm going to go sketch there, and I'm going to click revolve. As you can see, it's trying to do it about the vertical sketch axis. I don't want it about that axis. I want it about the horizontal. And there it is there. Our nice pizza disc looking thing. So what we could have done is just obviously made a cylinder and then used our fillet tool to make this edge. But the problem is you can't define the angle of the chamfer or the fillet in this, or the fillet in this point. So it would just be at 45. So in this case, if you needed it to be at 30 degrees, something like that, then you would have had to draw on this anyways. So we got our disc there. That's all looking good. We're happy with that. Click OK. So that's our revolution there. It's made up of this sketch. I'm going to unhighlight the sketch so we don't see it, because I don't really want to see the sketch anymore. So there's our disc. So now we can start making the teeth. Let's do that, because that's a hard part. There's a number of ways we can do this. You could make 40 or 50 different sketches and try to cut each one out of this pizza disc here. Or you could make one pocket like we did in the last tutorial, and then polar pattern that pocket all the way around, which is a lot easier. So you only need to make essentially one cutout and then duplicate it around. So, but remember, with polar patterns, only pockets can be patterned. So that's something to keep in mind. So you don't want to make an extrude and then, you don't want to make an object, cut it out of this one, and then try to polar pattern that cut, because it won't pick up the cut. It won't recognize it. So it's best always to do a pocket. So we're going to select the surface that I want to draw on. So that's the one there, and I'm going to create a sketch on that surface. So now that we got a sketch, I'm going to start making a cutout here. So in our thing, it kind of came down like this, looped a little bit, and then came back out. Kind of, what a tooth looks like. So maybe you start with a circle, definitely a circle in there somewhere for the bearings of the chain. And maybe it, actually I'm not going to use that, I'm going to use the polyline, so I have to keep clicking it every time. Maybe it comes up like this, and maybe there's a bit of angle on that as well, and then I'm just going to kind of put a random line out here. Doesn't really matter. Something like that again, and like that. And so now I'm going to use the slice tool, or the snip tool, to get rid of that thing inside there. And really important with the snip tool is these have to be connected or it won't snip it. So if it's not working, that's one thing to look into to make sure that it is working. So so now, as you can see, there's a lot of constraints here to do. There's lots of degrees of freedom. So right off the bat, since I kind of want this to be symmetrical, I'm going to impose some symmetrical constraints here. So click 2 points and the line that I want it to be symmetrical over, and then create a symmetry constraint. Create a symmetry constraint with those and with these here. So now if I change something over here, it's going to change on the other side. It's all mirrored about this axis right here. As you can see, this shows the 2 points that are constrained, and this little indicator here shows the axes that they're mirrored over. So maybe I want something kind of like this. Maybe this needs to be down farther. It needs to be kind of like that. Kind of like that. Maybe some dip like that. So that kind of looks like it could be a good cutout. Obviously, you can make these measurements if you're trying to duplicate something in real life. You can make these measurements, and then that's going to make things a lot easier. So I'm going to make this 7. Make everything a little bit smaller here. Diameter. I'm going to define a width there. Maybe I'm going to make that 10. Oh, see, so I messed up there. So I should have known that everything on this side measured from this axis over should be negative. So you see it crisscrossed it there. So we'll just go -10 and it fixes it right up. So maybe I'll make sure that that's constrained as well. So maybe go 15. There's still a little bit of angle there. Maybe I want these a little bit lower though. Yeah, it's kind of looking good. This looks really high though, so I'm going to move this up a little bit. Oops. I'm going to impose a constraint to make these tangent. So make some tangent, which is really nice. So let's choose this height here. That'll add some constraint. Go 140. Looks high enough. Choose this length here. So yeah, we'll leave it at that. That looks okay. Choose this length here, and as you can see, I've fully constrained it. So it's happy with everything. Happy, happy, happy. So now I can extrude this if I want. And if I want to make adjustments, like say I don't like these widths here, or something like that, or I don't want that to be negative, maybe I want that over here, or something like that, you can make the adjustments. So maybe I'll make this a little bit skinnier. So it obviously didn't like that I'm making it 9. I think that's because of this this length here, so you might need to delete some of these in order to adjust these the way you. Oh, it doesn't really like that at all. I might make that 11. Doesn't seem to like that at all. Not quite sure why. It's obviously not. Oh, there it is. Okay. Alright, so we'll try to make that again. I'm not sure why it wasn't liking that. Oh, it's because I forgot to delete it. There's something wrong over here, sorry. Delete that constraint there. There we go. So now, go back to 9. And yeah, maybe I won't make that one as much because I see what I did here, because I've actually defined the diameter of that circle there, and I've decided where the center of it was by making that way. It didn't like that, so make that 13 just to kind of get the right shape here. Yes, I mean, don't mind that. I should be able to hopefully make those tangent, I think. There we go. There's still 1 degree of freedom left. That height there, so I'm just going to select that height. There we go. So now she's fully constrained. Good to go. Alright, so now what we're going to do is we're going to make a... so this is one thing to consider when making gears and cogs and stuff like that, is obviously there's, you know, inner dimensions, but there's also outside dimensions as well, right? Like the width of the teeth here, there's going to be some dimension to those, right? And, you know, obviously the method I'm doing here, I'm not, you know, distinctly defining those. So I mean, but if you've defined these ones accurately and you've duplicated the exact number of teeth that there are, then, you know, by definition you've already defined the width of those teeth there, so that it should all work out. It should be good. So you should still be able to get the correct width of teeth and stuff like that. So so now that I'm happy with that, I can take that and I can pocket it. So you select the sketch so you want to pocket. You're going to click the pocket tool, which is this one right here. So as you can see, I'm going to make it through all. And so there's our pocket, our little cut there. So that's kind of like where one little chain eyelet would fit. So now what I want to do is I want to duplicate that over a couple of times, so maybe however many teeth there are on there. So I like that pocket. I'm going to click OK, and what I'm going to do is go up to polar pattern, and as you can see, it recognizes a pocket as something that it can pattern. So click OK. Get a better view here. So now I'm going to decide the number of teeth. So if you're obviously making something from dimension, then you'll know the number of teeth, so you just enter in however many teeth you need. In this case, since I've kind of arbitrarily decided the diameter of this and the size of the eyelet and stuff, I may have to play around with it to get the right number of teeth. So I'm going to try 30 right off the bat and see what that looks like. That's looking pretty close. Obviously the tooths are a little bit wide, so it's probably like 36 or something like that. It's probably closer. So remember, adding 1 isn't going to just shave it off. You know, adding 1, you're essentially taking, you know, however many you've already had previously and adding, you know, the 30th of each one to it. So that's looking better. That kind of looks more or less like a like an actual sprocket, I suppose. So that's looking good. Once you like it, click OK. And once your computer starts processing up, then you'll see that you've got your pattern there. So It's very nice, it's very easy, very quick, and the thing is if you don't like the shape of that, or you missed a dimension or something, you go back and you can edit this. Maybe this needed to be maybe this needed to be different dimension, or this this dimension here needed to be different. Maybe maybe this needed to be 9.5 or something, and it'll make the adjustments for you right there, and you'll see them occur here. So now you see that these are pretty straight, right? So I'm going to take it back to maybe 8.7 or something. You'll see that it'll make the adjustments to all of them in the polar pattern. So that's a really nice feature about that. So yes. So once you're happy with that, you can keep it like that. So that was one portion of it. And so as you recall, there was also cutouts of the sprocket as well. So we'll put those in as well. So click the face that you want to sketch on. Make sure that everything else is unhighlighted. Click on the face that you want. Click the Make New Sketch button, and you're back making a sketch on that face there. So which one is it? It's this one right here. All right. So where is it? No, it's. I don't know which one it is. Jesus. No, it's definitely this one. Alright, so you click on the face that you want to be on. Alright, so now what we're going to do is we're going to make that kind of weird shape there. So it's kind of a triangle looking curve thing. So I believe I did that with arcs. So you start with one arc up here. As you can see, this is a little bit difficult to see with, so you could either hide the rest of your sprocket, or you can just keep it where it is. It's entirely up to you. There's also a little bit rounded like that, and there was one at the bottom here that was centered. The nice thing about constraints is you can just kind of draw it out and not really care about where everything is, and then you just make everything fit later. So this isn't really looking like it, but it will in a little bit here. So we'll just put it together piece by piece here. So I'm going to kind of move things around here a little bit just to kind of make everything fit a little bit better. Alright, so as you recall, these curves were always tangents. So I'm going to use the tangent constraint, start making them tangent. But what I'm going to do before that is I'm going to make this all symmetrical. It's probably easier, because then I'll only have to do everything to one side. So I'm going to make those 2 points symmetrical. I'm going to make the centers of those arcs symmetrical about that axis. And I'm going to make, and I think that actually makes everything symmetrical. Yes, except for this circle here. So I'm going to make those symmetrical as well. There we are. So it's looking better. I'm going to make these circles equal, which will make it a little bit nicer so that I only have to define one of them. And I'm going to make it a little bit smaller. So I just want a small arc on there. And now I'm going to make these tangent, just on the one side anyways, which we'll do it on this side too because everything's all symmetrical. I think anyways. Oh no, didn't quite. That's because these 2 points aren't symmetrical either. So I'm going to make these points symmetrical as well. And there we go. It's a little bit better. Now I'm going to make those tangent as well, which will make that tangent as well. So as you can see, everything's looking pretty close. We're getting pretty close to the shape that we wanted. But as you can see, I can move this up and down to some extent. So now I'm going to give this a height here. I'm going to make this maybe 90. Oh, it doesn't like that. Something's happening here. So I think I've imposed too many symmetrical things here, so I'm going to get rid of a couple of them here. Maybe get rid of that. Oh, I think it has a problem with this one. Maybe this is a killer here. Yeah, so that was the one there. So, all right, so I'm gonna put those ones back because I think that was the one that was killing it. I believe it's this one right here that's giving me the trouble. So there's still a few glitches in this program, but you can kind of figure them out as you go, I suppose. So I'm going to give this a height here. What I'm going to do is make these two the same, which will kind of force everything else to be symmetrical. So that's a little bit nicer there. So we'll give that a height there. So sometimes you might have to do a little bit of backtracking to try to figure out why it's not working. So I usually always just go back to the last couple constraints that I made. If things aren't working out, then it's probably that one that's causing all the problems. So that's a height there. Maybe I'll define a width there. Go a little bit more, 45. Make it a little bit bigger. And I think if I just do a length on these, it's probably going to be pretty close. Not quite. So there's one more degree of freedom, so it's obviously that one there. So maybe I'll just define a height of one of these. Still, something can still change here. So the obviously the height of these will probably fully constrain it. There we go there. So I like that. Depending on how your things are dimensioned or how you measured everything will really denote how you constrain things. So as you can see, I've just locked down a bunch of stuff, right? But obviously you're not going to actually make these measurements, right? So obviously one would probably be the radius of this right here. So instead of this height here, you could actually probably just do the radius of this, which would be the exact same. It would still constrain it, but depending on how you're planning to measure all this stuff, will really denote how you're going to constrain it, right? So you could probably measure one of these. You could probably, kind of get an estimate of the diameter of those, diameter of that, where this sits in here. And, if you can't get it with this, then you can also make a bunch of construction lines to measure stuff from, to constrain stuff. So depends on how you want to do it. So once you're happy with something like that and you're fully constrained, you can close it, and we're gonna pocket this again. And so there's our pocket there, and I'm gonna go through all, click OK. And so there it is there, and maybe I want to polar pattern this now. So that was the pocket there. It recognizes the pocket. Click OK. It's going to bring up the polar menu. Decide how many occurrences we want, maybe 6 or something. If it can fit, ooh, just barely. So maybe only 5 in this case. Maybe only 5. So yeah, 5 will do there. 5 will fit nicely, and it doesn't look too stupid. So once you're happy with that, click OK. And from what I remember, we also had holes in here too, so that could be another tricky thing as well, especially when making the holes in the correct spots. So you could either reference it to a hole or an edge, or you could just try to set this up so that you know, things are in the right spot. So I'm just gonna open that sketch and see where everything is. So obviously we've got it centered on here. So you know, to make these holes, we're gonna have to, you know, make a couple patterns here. So I think what I'm gonna do is I'm gonna make this a little bit smaller. Make it 30. Oh, that's gonna be too small, I think. But oops, I forgot to make it negative because it's on the other side. There we go. Oh, it doesn't like that. It's too small. I'm gonna delete that. Make these in a little bit. So, you know, depending on if you're building something from a dimension, then this would obviously not be as hard. I'm trying to make this 40 here. Doesn't like that. Probably has to do with these here. So I'm going to delete that. Make that 40 and see what it does. Yeah, so that's a little bit better there. So. And based on that, that should still be able to make a tangent somewhere. I'm not sure why it's just got too many constraints or something, maybe. So it's over constrained. It doesn't like one of these, so I'm going to delete 13. Still 1 degree of freedom here. Oh, I see why. Okay. Based on this length here, it can't make that tangent, so I'm going to delete that there. I'm going to make those 2 tangent. So the problem was based on the new size, it couldn't make them. Yeah, it couldn't. I'm going to remake those symmetrical again because I kind of deleted that in the process, and that should fully constrain it there. So yeah, constraints can be a little bit challenging sometimes to try to figure out what's going on. I'm going to edit this polar pattern here by double clicking on it. Should bring it up and try 6 because 6 will be a little bit easier than 5 because I won't have to do a whole bunch of silly math. So like that there. Still a little bit close, so I'm going to edit that a little bit, maybe. Edit this sketch, maybe make this a little bit smaller, 38. Damn it. So it didn't quite like that. So I'm just going to keep it, actually. This is fine. There's too many constraints there, so. So now what we're going to do is we're going to put some holes in it. This one is centered, this one is centered, all these ones are not centered, so we're going to have to create kind of a bit of geometry in order to make this work, to get everything nice and straight, right? Because I'm going to make another sketch on this surface here. If I try to put circles there, it's going to be really hard to get them in the center here, right? It's going to be really challenging to figure out. So the best way to do that is by creating reference geometry. So I'm going to make a bunch of lines here. And what we're going to do is we're going to make them reference geometry. So that's turning them blue. So that means that they're not going to be included in the object, but they're used as reference for something. So what I'm going to do is I'm going to make just going to make those 2 actually, and then we'll polar pattern it. So what you could do is you can make 6 of these and then define the angles between all of them and then put circles on each one and then pocket those circles. Or what I could do is just make one over here, and then polar pattern exactly 6, and it should work out. So I'm going to make an angle between these two, being that there's 6 and it's 360 degrees. There should be increments of 60 between each, so this should be 30 degrees. So make that 30 degrees, and that'll put it perfectly in the center there, as you can see. And since it's also concerned in the length, I'm just going to lock that end in place there, so that it knows that the reference goes out that far. And what I'm going to do is make a circle. I'm going to attach it to that line. You see it attached there when it highlighted, except it actually didn't put it on the center. Why didn't it do that? I'm not quite sure why it's not sitting on there. 4, 6. I'm not sure what the hell is going on here. Oh, I see. It doesn't like that. Okay, there we go. So there's the circle there. So it didn't like the fact that I was defining a height there, so there's some glitch there. So now that we've got kind of set that end there, you can see that that lies on there perfectly. So why don't I just do that again, just to show it for argument's sake. So take your circle, the line highlights, showing that it wants to coincide that circle, the center of that circle, with that line. So click, yeah, that's what I want, and then you decide its diameter, and then you can move it around on there. So I'm going to define a radius that this hole needs to be at. Oops. I guess it would just be just a height then. Or or what you could do is you could also have a instead of that, if you only had the radius, you could use a circle also as so I'm going to coincide with that point there. You can also use a circle as reference geometry. So now this circle here is not only going to be attached to this point, but it's also going to be attached to this circle. So if I decide the diameter of this circle to be 60, it's that circle right there. This one is always going to be on that line there. So I'm going to decide the diameter of our hole. We're going to make it 8 millimeters. Oops. And as you can see, it's nicely in the center here. I can decide any radius I want it to be at. So maybe it needs to be at 65. That'll put it up a little bit. Maybe it needs to be at 60, whatever you measure, right? So now that you're happy with that, and it's fully constrained, you can close the sketch, and then what we can do is we can pocket it as before. So you select the sketch, and you're going to click Pocket. You're going to go through all, you're going to click OK. So now you've got a pocket there of one hole, and then now what we can do is polar pattern just as we did before, pocket number 2, because pocket number 1 and the original pocket were the sprockets in those holes there. So we want pocket number 2, click OK. It's going to bring up the menu again, and then you can just choose 6, because that was the measurement we made out based on the geometry. And so you see that it's centered in each one. Right, you can see that these holes have been centered between each one perfectly. So that's one way we can efficiently do things by only having to, define the geometry of this one, and we know that we're going to replicate it 6 times so that it's going to coincide with all of these holes as well. You can kind of save yourself some time. So when you're happy with that, you click OK, and there's your sprocket. Doesn't look quite exactly like the other one, and that's just because of these dimensions. I think it looks a little funny, but that's generally how you do it. And when I made the other one, I think I precisely measured everything off an original sprocket that I had with me. So the other one that I had, it actually is replicate of a real one in real life, and so it worked out quite nicely. So yeah, so that's and if you're happy with it, you can save it, and you can make it an object. So if you wanted to export it, you gotta make sure you convert it to a solid. Once you got a solid, you can rename it whatever you want. Sprocket 36 tooth, and you're done. So, and obviously later on I'll talk more about building assemblies and stuff like that, which can be a lot more complicated. Which that means that there's multiple objects, kind of all, you know, if you're building or designing something, then you're going to individually create all the objects in separate files, and then you'll build an assembly file in which you bring them all together into that one file. So maybe we'll talk about that later once we kind of get a few other tutorials here. So I think this pretty well encompasses revolving and cutting stuff. So I may do one or two more. One more maybe on a pulley with other notches and doing some complicated cuts and stuff. I may also show you how to make turbines and stuff, so I'll show you another really helpful tool to use, and that's in the part workbench here, and it's called the sweep tool, sweeper loft. So these are also really handy, and I'll show you how to use those in the next tutorial. So till then, cheers.